Now we will learn about sight distance. Sight distance available from a point is the actual distance along the road surface which a driver from a specified height above the carriageway has visibility of stationary or moving objects, or we can say it is the length of the road visible ahead to the driver at any instance. Sight distance is the length of the road surface which a particular driver can see with an acceptable level of clarity. Sight distance plays an important role in geometric highway design because it establishes an acceptable design speed based on the driver's ability to visually identify and stop for a particular unforeseen roadway hazards or pass a slower vehicle without being in conflict with opposing traffic. As velocities of roadways are increased, the design must be catered to allow additional viewing distance time to stop. So here in the figure also you can see that if you are moving along the road and this is the height of the eye wherever the driver will be sitting. So depending upon the height of the eye, he should be able to see, that is the line of sight. And if there is a curve portion, okay, s is the distance between two objects, still then he can see the object. There is a object here, height of object, he should easily be able to see that is the height of the eye should be such that it should be properly able to see the object. Also there are different types of sight distances like stopping sight distance, also called as SSD, or also called as absolute minimum sight distance. Next, safe overtaking or passing sight distance, or also it is called as overtaking sight distance, OSD. Next, safe sight distance for entering into uncontrolled intersections. Next, intermediate sight distance, and lastly headlight sight distance. So all these 5 types of sight distances we will be studying in depth one by one. Okay, the computation of sight distance mainly depends on reaction time of the driver, speed of the vehicle, and efficiency of the brakes. Okay, now what is stopping sight distance? Simply, in short, we will see stopping sight distance is the minimum sight distance available on a highway at any spot should be of sufficient length to stop a vehicle traveling at a design speed safely without collision with any other obstruction. Means if you stop behind any other vehicle, there should be a sufficient space between two vehicles such that the collisions can be avoided. Overtaking sight distance. The minimum distance open to the vision of a driver of a vehicle intending to overtake slow vehicle ahead with safety against the traffic of opposite direction is known as the minimum overtaking sight distance or the safe passing sight distance. Okay. Sight distance at intersections. Driver entering an uncontrolled intersections has sufficient visibility to enable him to take control of his vehicle and to avoid collisions with another vehicle. Intermediate sight distance. This is defined as twice the stopping sight distance. It is very simple. Intermediate sight distance is simply double the stopping sight distance. When overtaking sight distance cannot be provided, intermediate sight distance is provided to give limited overtaking opportunities for the fast moving vehicles. Headlight sight distance. This is the distance visible to a driver during night driving under the illumination of the vehicle headlights. The sight distance is critical at upgradient and at the ascending stretch of the valley curves. Now we'll study stopping sight distance in detail. Now see friends, from here onwards all the topics are very important. Pay attention clearly. So what is exactly stopping sight distance? Stopping side distance is the minimum distance available on the highway at any spot having sufficient length to enable the driver to stop a vehicle traveling at a design speed safely without collision with any other obstruction. Or else we can also say it is the distance needed for the driver to see any object on the roadway. The distance are derived for various design speeds based on the assumptions for driver's reaction time, braking ability of most vehicles under wet pavement condition, and the frictions provided by the most pavement surface, assuming good tires. A roadway design to criteria employ a horizontal and vertical alignment and a cross section that provides at least the minimum stopping side distance through the entire facilities. For the purpose of measuring the stopping side distance or visibility ahead, the IRC has suggested some values. The IRC has suggested some values that height of the, here you can see the height of the eye level of a driver, it should be 1.2 meter, capital H. Okay, height of a driver is 1.2 meter and height of an object should be 0.15 meter. Height of an object should be 0.15 meter, height of a driver should be 1.2 meter. Stopping side distance mainly depends on these two important criteria. Okay. So in this figure again you can see length of the curve. If you are moving along a curved path, okay, if you, this is a cross section, if you are moving along the curved path, then here h1 is the height of the driver and h1 again is the height of the driver, and there will be another object, small object with a height of 0.15 meter, and this length of the curve should be such that this person moving along should properly see another objects clearly. Now there are some factors affecting stopping side distance. These are total reaction time of the driver, speed of the vehicle. Now how the speed of the vehicle will affect? Higher the speed of the vehicle, more time will require to stop the vehicle. Hence, speed increases, stopping side distance will also increase. Okay. Next factor, efficiency of brakes. If we are applying 100% efficiency, vehicle will stop immediately. Then there is chances of skidding and it leads to accident ultimately. So for the design purpose, the vehicles are always considered for 50% of braking efficiency. Okay. Then gradient of road. Always there are two types of gradient on road. Remember, ascending gradient and descending gradient. In ascending gradient, stopping side distance will be less, but in descending gradient, stopping side distance is more because gravitational force comes into picture. Lastly, frictional resistance between road and tire. When the frictional resistance will be more, the vehicle will stop immediately and side distance required is less and vice versa. On a single lane road where there is a two-lane traffic permitted, the minimum stopping side distance is twice as that as a stopping side distance to avoid heads-on collision. Okay, this you remember all the points. And now what exactly is reaction time of the driver? Reaction time of the driver, see, for this we have one theory called as a PIEV theory. Okay, this figure will clearly show you what is PIEV theory. Look at the figure on the right side. P stands for perception, I stands for intellection, E stands for emotion, and V stands for volition. Okay. Now what is perception? It is the time required for the sensation received by the eyes or ears to be transmitted to the brain through the nervous system and spinal cord. Whatever you see or whatever you hear will first go into your brain. So, this is your first step, perception. Intellection. It is the time required for understanding the situation. Whatever you hear or whatever you see will be first interpreted by your brain, that what exactly is the situation. Okay. Then emotion. It is the time lapsed during emotion sensation and disturbance such as fear, anger, or any other emotional feeling such as superstitions, etc., with reference to the situation. Depending upon the situation, you will react. Either you will be emotional, either you will be angry, depends. Okay. And volition, it is the time taken for the final action. So after any incident takes place, there is all the PIV theory taking place inside the human brain to percept and react is known as PIV theory. This is also very important from your examination point of view. Total reaction time. Now all this PIV take place inside a human brain. This only takes around 0.5 seconds to 4 seconds. So total reaction time of a driver may vary from 0.5 seconds to 4 seconds. See how fast the brain takes the decision. Hardly 0.5 seconds to 4 seconds are required. Now, analysis of the stopping side distance. The stopping side distance is the sum of lag distance and braking distance. Now, what is this lag distance? It is the distance the vehicle traveled during the reaction time. Now, is it like that you are thinking and you have stopped a vehicle to a particular station? Obviously, no. Till you think, the vehicle will go on continuing. So, during this reaction time, whatever the distance is traversed by the vehicle is called as a lag distance. If V is the design speed in meter per second and T is the total reaction time of the driver in seconds, then lag distance is denoted by V into T in meters, where V is in meter per second and T is the reaction time of the driver. It is taken as 2.5 seconds. It is the worst condition considered here. T is equal to 2.5 seconds. Now, if V is given in kilometers per hour, listen carefully. If V is given in kilometer per hour, then this formula will simply change to 0.278 into V into T, where V is in kilometers per hour. If V is given in kilometer per hour, this formula for lag distance you will get it in meters, where T is again 2.5 seconds. Now, braking distance. It is the distance traveled by the vehicle after the application of the brakes. For the level road, it is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. Work done against friction force is stopping the vehicle is 1 into F is equal to F into W into 1, where W is the total weight of the vehicle. The kinetic energy at the design speed of V meter per second will be 1/2 mv square. So, braking distance is equal to V square upon 2gf. Very important formula. As we already said, stopping side distance is equal to lag distance plus braking distance. Therefore, totally the formula comes to as stopping side distance is equal to 0.278 V into T plus V square upon 254 into F. Okay. Now, here if you want, there is again one more formula, simple formula, as SSD, stopping side distance, is equal to V into T plus V square upon 2gf. V square upon 2 into G into F. Whatever formula I told, this is for the formula if V is in meter per second. Whatever formula is displayed, that is for V given in kilometer per hour. Okay, whichever you feel easy, you can use that. Now the below table shows you the coefficient of longitudinal friction, where speed is in kilometer per hour and longitudinal coefficient of friction values you get from this table. Okay, so if the speed is 30, longitudinal coefficient of friction is 0.4. If speed is 40 kmph, longitudinal coefficient of friction is 0.38. For 50 kmph speed, longitudinal coefficient of friction is 0.37. For 60 kmph speed, longitudinal coefficient of friction is 0.36. And if the speed is greater than 80 km per hour, longitudinal coefficient of friction is 0.35. For two-way traffic, single lane road, stopping side distance is always taken as double. And in one-way traffic with single or more lane, or two-way traffic with more than single lane, minimum stopping side distance is kept as it is. We will solve some numericals. Okay, so we will stop here and solve some numericals in next lecture.